Dear students, today we will discuss about what is the application of amplifiers in the electronics field, and what is the applications in different fields of amplifiers. So first one is the significance of use as amplifier in cascade mode. So resistor of each stage is coupled into the base of the next stage. So this is the coupling between two amplifiers by the resistance or capacitance components, and we connect one state to another state by the use of resistor and capacitance. So this type cascade is the RC coupled cascade amplifier. In this case, the overall gain is the product of the individual gain voltage from one state to another state, and to improve the gain in cascade amplifiers, the most widely used methods coupling a signal from one stage to the another stage and block DC. So capacitor used as a blocking of DC component from the AC component. So capacitor pass the AC signal and block the DC signals. So we view also in multi-stage amplifiers, and we connect one amplifier to another amplifier and second amplifier to third amplifier and so on. So this type of connection in which more than one amplifiers are connected, that is the multi-stage amplifier. So in multi-stage amplifiers are amplifier circuit cascaded to increase gain. So we can increase the gain by using the multi-stage amplifier process. We can express gain in decibel dB of these multi-stage amplifiers. Two or more amplifiers can be connected to increase the gain of an AC signals, and also we connect the more than two or more than three amplifiers by the R or C coupling components, and the overall gain can be calculated by simply multiplying each gain together. So in this figure we have, there are different multi stage connections and have the different amplifiers which have the voltage gain of AB1, AB2, AB3 and so on, and these are connected in series to each other, and so the overall gain of the multi-stage amplifier AB will be equal to gain product of each amplifiers. So AB equal to AB1 into AB2 into AB3 and so on. So that is the overall gain of the multi-stage amplifier. For examples, in this figure, we have the different voltage gain of each amplifiers, and we have here the input voltage is 5 millivolt, and what is the output voltage. So we can easily find out the output voltage with the help of these given data, because we know that the voltage gain equal to output voltage upon input voltage. So we have the values of input voltage and different gains, so we can easily find out the output voltage. So we have the AB1 voltage gain 5, AB2 voltage gain 10, and AB3 6, and ABN is 8. So with the help of formula of the output voltage, V naught will be equal to gain multiply input voltage. So we can easily find out the output voltage of this multi-stage amplifiers. Next one is the what is the construction of two-stage amplifier in a cascade conduction. So, so a cascade amplifier is any two-port network constructed from a series of amplifiers where each amplifier sends its output to the input of the next amplifier in a chain system. The complication in calculating the gain of cascade stage is the non-ideal coupling between stage due to loading. So in this given figure, that is the two-stage amplifier in cascade configuration. So we have in this two-stage amplifier, there is two transistor. One is transistor Q1 and second is transistor Q2, and these two transistors are connected by the direct coupling technique. So this is the two-stage cascade configuration in which different biasing resistance and different capacitors also used here across the base and collector terminal also. So the use of these capacitor block the DC signal and pass the AC signals. So this is the construction of two-stage amplifier in a cascade configurations. Next, this figure shows the small signal equivalent circuit of the cascade configuration. So small signal gain of a cascade amplifier determine the voltage gain at stage first and stage second. So AB equal to AB1 into AB2. So AB1 and AB2 are the voltage gain of two amplifiers. AB1 gain of the first amplifier and AB2 is the gain of second amplifier. Therefore, AB equal to, we know that the AB equal to V naught upon Vs, and also equal to Gm1 Gm2 into Rc1 parallel to R pi 2 into Rc2 parallel to RL into Zn upon Zn plus Rs. So the gain in decibel, so the gain in decibel will be AB equal to 20 log of gain AB. So here input resistance in the given equivalent circuits of small signal cascade configuration, that input resistance equal to R1 parallel to R2 parallel to R pi 1. So assume here Vs equal to 0, so V pi 1 equal to V pi 2 and equal to 0. Else also Gm1 V pi 1 equal to Gm V pi 2 equal to 0. So output impedance Z out will be equal to RC2 parallel with RL. So here in this circuit diagram, this is the two-stage coupled amplifier, and coupling is done by the capacitor, and draw the AC equivalent circuit and calculate the voltage gain, input resistance and output resistance for the Cascade BJT amplifier in given figure. So this Cascade BJT amplifier given here, we first of all draw the AC equivalent circuit, and after the AC equivalent circuit, we calculate the voltage gain, input resistance and output resistance for the this Cascade BJT amplifier. So we have VCC R1 equal to R3 and equal to 50 kilo ohm. This is the value of R1 and R3 given here, and also R2 equal to R4 equal to 4.7 kilo ohm, and RC1 equal to RC2 equal to 2.2 kilo ohm, and also emitter resistance RE1 equal to RE2 also given here equal to 1 kilo ohm. So why the DC analysis of this given cascade amplifier? At the Q1, that is the transistor Q1, we have the base current at the Q point IB Q1 equal to 19.89 microampere and IC Q1 equal to 3.979 milliampere. And also at the transistor Q2, we have the base current IB Q2 equal to 19.89 microampere, and also the same collector current as in transistor Q1, 3.979 milliampere. So AC analysis, we find out at Q1 R pi 1 equal to 1.307 kilo ohm, and GM1, that is the transconductance, will be equal to 0.153 S. And at the Q transistor R pi 2 equal to 1.307 kilo ohm and GM2 equal to 0.153 S. From the AC equivalent circuit, at Q1 the voltage gain is AB Q1 equal to B naught Q1 upon VI, and this is equal to minus GM, and resistance RC1 parallel to RI2, where V naught Q1 is the output voltage looking to the Q1 transistor, and RI2 is the input resistance looking into Q2 transistor. So therefore RI2 equal to RV2 parallel to R by 2 equal to 15K parallel to 4.7 parallel to 1.307K. So this will be equal to 957.36 ohm. The voltage gain at Q1 is AB Q1 equal to 0.153 into parallel of two resistance, that is the 2.2K parallel to 957.36. So overall gain equal will be equal to minus 102.06. Next, from the AC equivalent circuit at transistor Q2, the voltage gain is ABQ2 equal to V naught upon VIQ2 equal to minus GM RC2, where VIQ2 is the input voltage looking into the Q2 transistor. So therefore voltage gain at Q2 equal to, put the value of GM and RC2, and we have the VABQ2 equal to minus 336.6, and overall gain is AB equal to ABQ1 into ABQ2. So this, that is the multiply or product of the two voltage gain of different two stage amplifiers, and this will be equal to 34,353. So the large overall gain can be produced by multi-stage amplifiers. So the main function of cascade stage is to provide the larger overall gain. So this is the uh, advantage of the cascade stage amplifier, because this is provide the larger overall gain of the amplifiers. So from the AC equivalent circuit, the input resistance also can be calculated by the R input equal to R1 parallel to R2 parallel to R pi 1. So put the value of here R1, R2 and R pi 1, and after the calculation we find out the value of Ri, that is equal to 957.36 ohm, and also we can find out the output resistance, that is the R naught will be equal to RC2, and that is the 2.2 kilo ohm. Here RC2 is the resistance across the transistor Q2 terminal collectors. In these different diagrams given here of the multi-stage amplifier, in which two-stage or three-stage amplifier are used here. So first circuit diagram show the three-stage multi-amplifiers and by the capacitor coupling, and second one is the two-stage direct coupled amplifier, and third one is the two-stage capacitor coupled amplifiers, and fourth one is the two-stage coupled by the capacitor amplifier. So these are the different multi-stage amplifiers. So there is the different amplifiers, and they have the types of different amplifiers, and the signal and voltage and current, vacuum tube amplifier and multi-stage amplifier, and we have also operational amplifiers. So in multi-stage amplifiers, a transistor circuit in which number of amplifier stages are cascaded one after another in series. Coupling device, the device which connect the output of one stage to the input of the next stage. So depend on the manners in which the different amplifiers stage are connected, one of the following amplifiers may results: RC coupled amplifier and RL coupled amplifier. So first stage of amplifier and second stage of the amplifier, there is a coupling device between these two, that is the RC network or RL network. So first one circuit diagram in this figure show the Cascade RC coupling, because here we use the coupling R and C network. And next one is the transformer coupling. We also couple one amplifier to second amplifier by the transformer coupling. And third one is the Darlington or direct coupling method, in which one stage direct connect to the second stage. And also in cascade amplifiers, we connect the one amplifier to the another amplifier on the vertically. These two amplifiers are connected in cascade coupling configuration. So function of coupling device to transfer only AC output of first stage to the input of the next stage. So capacitor block the DC component and pass the AC component. So in output of one stage is connected to the input of another stage. So here overall gain is AB equal to B naught upon B input, or equal to product of two stage amplifier gain AB1 multiplier AB2. So if we connect the more than one stage, and each stage have the gain G1, and second is G2, third is G3. So overall gain is the product of these different stage gains. This figure here show the frequency response of the cascade amplifier. So this is the graph between voltage gain versus different frequencies. So we find out the bandwidth with the help of this frequency response of a cascade amplifier. So bandwidth is the difference of two frequency. So suppose here FR is the resonant frequency and FH is the upper high frequency and FL is the lower frequency. So we can find out the bandwidth with the help of these upper lower frequencies. So bandwidth equal to FH minus FL. That is the bandwidth of the amplifiers. So bandwidth the range of frequency over which gain of the amplifier is equal to or greater than 0.707 to 70.7% of the maximum gain. And this bandwidth also given in this frequency response curve here. So this circuit diagram show the two-stage RC coupled amplifier, in which coupling done by the capacitor and Here the R1 and R2, R3 and R4 in this two stage RC coupled amplifier on the voicing and stabilization network. That is the use of R1, R2 and R3 and R4. That is from the voicing and stabilization networks in the circuit diagram. And input capacitor Cin couples the AC voltage to the input, and the capacitor Ce, known as the emitter bypass capacitor, used to offer low impedance to the AC signal. So this is the use of the emitter bypass capacitor that is used to offer low impedance to the AC signals. The coupling capacitor CD couples the output of first stage to the input of second stage. Since the coupling capacitor passes only AC signal and block the DC signals, that's why coupling capacitor called blocking capacitor, because this capacitor block the DC supply. The overall gain is less than the product of gain of individual stages. So second stage is made to follow the first stage. The effective load resistance of first stage is reduced because of the input resistance of second stage. This reduces overall gain of the output. So frequency response of the two-stage amplifiers, curve plotted between frequency and gain. So case first, here when frequency is less than 50, because in this figure given different frequency in hertz and also gain in here. So a part of AC output of first stage is low capacitor CD, which offer very high reactance at very low frequency, because XC equal to 1 upon 2 pi FC. This is the capacitive inductance. At very low frequency, common emitter bypass offers higher reactance and could not shut the emitter resistance RE. And second case, at very high frequency, the reactance and CC coupling capacitor become very small and it's behave as a short circuit. So the loading effect of next stage. So this in next case third, the mid frequency range between 50 Hz to 50 kilohertz gain constant. In this frequency range, frequency increase, reactance of CC decrease, which increase the voltage gain, decrease in reactance, producing higher loading effect of first stage, which decrease the gain. This means both of these factors maintain constant gain at mid-frequency range. So there are some advantage of multi-stage amplifier or cascade amplifiers. It has lower cost since it employs resistors and capacitors which are cheap. Second is it has excellent frequency response. The gain over the audio frequency range, which is the range of most important of speech, music, etc. The circuit is very compact as the modern resistor and capacitors are small and extremely light. So these are the some advantage of these multi-stage amplifiers. And we have some disadvantage of these cascade or multi-stage amplifiers here. So they have the tendency to become noisy with age, particular in moist climate. So this is the disadvantage of these cascade amplifiers and multi-stage amplifier. The RC coupled amplifier have low voltage and power gain. And next one is the impedance matching is poor in this multi-stage amplifier. So because the output impedance of RC coupled amplifier is several hundred ohms, whenever input impedance is only a few ohms. Hence, little power will be transferred to the speaker. So these are the some disadvantages of the multi-stage cascade amplifiers. The RC coupled amplifiers have excellent uh, over a wide range of frequency, and therefore they have widely used as voltage amplifier. Note if even number of cascaded stage 2, 4, 6, the output signal is in this case, the output signal is from the odd cascade stage. So this is the reference books for this topic, electronic device and circuit by Millman and Alkias. So we have basic parameters of a transistor amplifiers, and a good amplifier must have all the following specifications. First one, it should have high input impedance, and it should have high stability, and it must have high linearity, and it should have high gain and bandwidth, and also it must have high efficiency. So this is the basic parameters of any amplifiers, and also a good amplifier. And a good amplifier must have follow these following specifications. So bandwidth So what is the bandwidth of an amplifiers? The range of frequency that an amplifier circuit can amplify properly is known as the bandwidth of that particular amplifiers. The curve below responds the frequency response of the single stage RC coupled amplifiers. Each curve, which represent the variation of gain of an amplifier with frequency, is called frequency response curve. The bandwidth is measured between the lower half power and upper half power point. P1 point is lower half power and P2 is upper half power respectively. So a good audio amplifier must have bandwidth from 20 Hz to 20 kilohertz because that is the frequency range which is audible, or this is the frequency of range of audio signal. And what is the gain of any amplifier? So gain of an amplifier is defined as the ratio of output power to the input power. Gain can be expressed either in decibel or in numbers. So gain represents how much an amplifier is able to amplify a signal given to it. So this is the gain. Gain represents how much an amplifier is able to amplify a signal given to it. So this equation represents gain in number. So gain is the output power on input power. So gain is the ratio of output power to input power. And where P output is the output power of amplifier and P in is the input power of the amplifier. The equation below represents the gain in decibel. So a simple gain convert into decibel by this given formula. So gain in decibel equal to 10 log of gain, that is the P output upon P input. So this is the gain conversion formula of a simple gain into decibel gain. And gain can also be expressed in voltage and current. The gain may be voltage gain, current gain also. Gain in voltage is ratio of output voltage to the input voltage, and gain is current is ratio of output current to input current. So equation for gain in voltage and current is shown below. So gain in voltage equal to output voltage upon input voltage, and gain in current equal to output current upon input current. So this is the gain, voltage gain and current gain formula. And high input impedance. So a good amplifier, the input impedance must be high. Input impedance is the impedance which is offered by an amplifier circuit when it is connected to the voltage source. The transistor amplifier must have high input impedance in order to prevent it from loading the input voltage source, so that is the reason for having high impedance in the amplifiers. Next one is the noise. So what is the noise role in amplifiers. So basically noise is the unwanted signals, and noise refer to unwanted fluctuation or frequency present in signals. It may be due to interaction between two or more signals present in a system, component failures, design flaw, external interference, or maybe by virtue of certain components used in the amplifier circuit. Next parameter of transistor is the linearity, or next parameter of any amplifier, that is the linearity. An amplifier is said to be linear if there is any linear relationship between the input power and the output power. So linearity represents the flatness of gain. Practically, it not possible to get 100% linearity as the amplifiers uses active device like BJT, JFET, and MOSFET, which tend to lose gain at high frequency due to internal parasitic capacitor. So in addition to this, the input DC decoupling capacitors sets a lower cutoff frequency. Next parameters of any amplifiers is the efficiency. So what is the efficiency of any amplifiers? The efficiency of amplifier represent how an amplifier can utilize the power supply efficiently. The efficiency of amplifier represent how an amplifier can utilize the power supply efficiency, and the measure how much power from the power supply is gainfully converted at the output. So efficiency is usually expressed in percentage, and the equation for efficiency is given P output upon P supply into 100. So where P out is the power output and PS is the power draw from the power supply. So a class A transistor amplifier has 25% efficiency and provide excellent signal reproduction, but the efficiency is very low of class A amplifier, and class C amplifier has efficiency up to 90%, but the signal reproduction is bad. So class AB stands in between class A and class C amplifier. So it is commonly used in audio amplifiers applications. This amplifier has efficiency up to 55%. Next one is the slew rate. So slew rate of an amplifier is the maximum rate of change of output per unit time. It represents how rapidly the output of an amplifier can be changed in response to change in the input. So that is the slew rate. Next parameter is stability. So stability is the capacity of an amplifier to resist oscillations. Usually stability problem occurs during high frequency operations, close to 20 kilohertz in case of audio amplifiers. The oscillations may be of high or low amplitude. So amplification is a process of increasing the signal strength by increasing the amplitude of a given signal without changing the characteristics of an RC coupled amplifier is a part of multi-stage amplifier wherein different stages of amplifiers are connected using a combination of resistor and capacitor. An amplifier circuit is one of the basic circuit in electronics. So there are some multi-choice questions for this topics. So these are the different multi-choice questions. So thank you very much.